Hello students, in this video we will be discussing Cbse class 9 physics from NCERT science textbook chapter 8 motion. Okay, so already we have discussed few of the previous parts in till part 9 and now we are going to look at part 10. We are doing with the graphical representation and we've already learned that we have two different types of graphs. One is the distance time graph and other one is the velocity time graph. Okay, so we discussed the distance time graph till now in the previous videos. So we learned about the concept of slope. So those who are not thorough the concept of slope, please go through it, okay, because it's a very important concept. So what is slope? We learnt it is nothing but rise divided by run. Okay, that is change in the y coordinate by change in the x coordinate. Okay, so with the nature of the graph, we were able to interpret the type of motion in the distance time graph. Here you can see two different types of graphs and you can try interpreting the nature of the motion of the object. Now we will be discussing the velocity time graph. So in distance time graph, we saw that distance was plotted along the y-axis and time along the x-axis. Likewise, in velocity time graph, we will have the velocity being plotted on the y-axis and time in the x-axis. Okay, that is what is given here. So as we saw about different cases for distance time graph, we have different cases for the velocity time graph also. So I hope you will all remember that for the velocity time graph, when you have the graph to be parallel to the time axis, okay, where distance was on the y-axis, if you had the graph parallel to the time axis, we said that the slope is 0. And we also know that the slope gave us the speed of the object for a dt graph, distance time graph. Okay, here we don't talk about stationary objects because here it is already velocity time graph. So when will you plot velocity time graph? Only when when the object is in motion, because if there is no motion, the stationary object, then the velocity will be what? 0. Your graph will be on the x-axis only. Okay, so what is the only case you might have with velocity, either uniform or non-uniform? Okay, so with uniform velocity, what do you have here? Okay, so when you have uniform velocity, we know that at every point of time it is going to move at the same velocity or the same speed. So in that case, we can see that the slope is a straight line parallel to the time axis. Okay, so in such a case, we know that the slope is going to be 0. So this is the interpretation. We will see what is slope and all in the later on with the other cases. Okay, the first case, just remember that for an object moving with uniform velocity, the slope is 0. Okay, now we will see about uniform acceleration. We learned about what? We learned about uniform velocity. Now we are learning about uniform acceleration. Acceleration means what? The velocity is going to change. Okay, so velocity is, so I can say that the velocity is going to be non-uniform, or I can say it is going to change uniformly. Velocity is going to keep changing uniformly. How? With respect to this acceleration. If the velocity is going to change, you say that that is going to be acceleration, and this acceleration is uniform. What will be the other cases? Non-uniform acceleration. Okay, so first we will see about acceleration being uniform, and in this also we have two cases. Okay, the first case we are seeing that the object is starting from rest. The object is starting from rest. Rest means we know that u is 0. The initial velocity is 0, and then it might reach a final velocity v. Okay, the initial velocity is v0 and the final velocity is going to be v. So this is our slope. Now what will be the value of slope? So if this is point O, then what will be OA? If I am going to drop a line here, OA and B, then my slope will be AB by OB. AB by OB. So what is AB? AB is nothing but V minus U. And what is OB? OB is t. What is v minus u by t? You must all remember that v minus u by t is what? Rate of change of velocity. Okay, rate of change of velocity is what? Acceleration. Rate of change of velocity is acceleration. So we can conclude that the slope of a VT graph will give us the acceleration of the object. The slope of a VT graph will give us the acceleration of the object. That is our interpretation. Okay. That is what is written here, the first few points. First we look at it. Okay. So the graph is a straight line inclined to the time axis. So what is slope? Rise by run. What is rise by run? V by v minus u by t. That is what we say that change in velocity. So v minus u by t is nothing but change in velocity with respect by time. Okay. So what will our slope give? Our slope will give the acceleration of the object. Okay. Thus, slope of a VT graph will give the acceleration of the object. So, greater the slope, greater the acceleration. Okay, the slope is going to keep changing. So, the slope is going to be like this and like this. We can say that if this is going to be OA and OB, we can say that line OB will have a greater slope than the line OA. Okay, that is what is given here. Greater the slope, greater will be the acceleration. Okay, after this we have one more concept to be learnt. Okay, so what is that concept? That concept is nothing but area. That concept is nothing but area. For a dt graph we only calculated the slope, but for a vt graph you have to calculate the area also. Okay, so area means area of what? Area under the graph. So that means what? This area. Okay, so this part, this part is what we will calculate. So area under the curve. Okay, so this area we will have to calculate. So if I am going to calculate this area, what will it be? Half into base into height. My base will be time, my height will be change in velocity. Okay, so what is velocity into time? Velocity into time is what? Displacement. Okay, so magnitude of displacement or the distance. Okay, magnitude of displacement or the distance is what we will be seeing here. Okay, you can see that here. Okay, so magnitude of displacement or the distance. Hope you understood this. Okay, so if not, please, if not, just I'll write this definition so that I hope you will be able to recollect. So what is distance? Speed by time. Okay, so what is this is speed by time. So displacement is what? Velocity by time. Correct? So what will be displacement is velocity into time. Okay, sorry. So what we have here is, so we have speed. Speed is equal to what? Distance by time taken. Correct? What is velocity? Velocity is what? Displacement by time taken. Displacement by time taken. So here we have velocity into time. So that will give you the displacement. So area under the graph will give you the displacement of the object. That is our conclusion. Our conclusion is that the slope will give you the acceleration and the area will give you the magnitude of distance or the magnitude of displacement or the distance. Okay, so you will have to remember this. So for a dt graph we only calculate the slope which gives us the speed. For a vt graph you calculate the slope which gives you the acceleration and the area which will give you the magnitude of displacement or the distance. Okay, again this is for an object starting with rest, that is with zero velocity. Okay, now we are going to consider an object which is going to start with some initial velocity u. Okay, so that means this is what? U, and this point is what? V. So what will be the slope? for the slope you will have to extend this line here and here. So let me take this to be AB. So what will be the slope? ABC. So BC by AC. So BC by AC will be what? Again V minus U by T, which will give the acceleration. So slope will give you what? Acceleration. Now what about the area under the graph? So area under the curve. So while we calculated the slope, we only calculated till this. Correct? We only calculated till this. But when you are calculating the area under the curve, you will not stop with this, but you will also find out the entire area. Even this area you will have to find out. Okay. So for this, what do you have here? You have a trapezium. This big trapezium is there. Let me name it O, A, B, C, D. Okay, so you have a trapezium O, A, B and D. Okay, so for this trapezium we will have to find out the area, or you can divide it into a rectangle and a triangle and then calculate. Okay, so this is about finding the slope and the area under the curve for an object starting with an initial velocity. Okay, so you'll have to be careful. So the previous case was an object starting from rest. This is for an object starting with initial velocity and then it is moving with uniform acceleration. Is it clear, children? Okay, so this is going to be only for uniform. For non-uniform, we'll be seeing in the next video. Hope you understood. If you have any doubt, please listen to it again and then you will be able to understand. Okay, so with this we are completing with the VT graph. Okay, VT graph, the first part. Okay, VT graph, the first part we are going to complete. We already completed the DT graph. What we need to remember is, for a DT graph, the slope will give the speed of the object. Okay, but for a VT graph, the slope will give the acceleration and the area under the curve will give you the distance or the displacement. We can calculate both from a single graph. Okay, children. So all that we will be seeing when we discuss the numericals. Okay, hope you have understood this. If you have any doubt, listen to the video once again. If you have doubt in the concept of slope or acceleration or distance or displacement, any previously learned concepts, please get back to the previous videos and then try to understand. So see you again in the next part. Thank you, children.